Bismillahirrahmanirrahim and Assalamu alaikum to you all. Hope you all are fine. In this particular tutorial, we will be doing an analysis on ANSYS Workbench of this particular beam that you can see over here. It is a simply supported beam which has a length of 49 inch and a height of 2 inch. Height of 4 inch. Let me correct it. Height of 4 inch. And it has an in depth of 2.5 inch, which will be not the part of simulation right now, but will be in the next part of our video series. So there will be two parts of this video. In the first part, we will be doing a 2D analysis in which we will be having a very less thickness of about 0.01 inch, and we will do the analysis at that point. And in the second part of the video, we will incorporate this width of 2.5 inch, and then we will do the simulation, and inshallah we will be having much more results in that part of the video. Now coming to the simulation, go to statistical structural, double click on it and go to geometry. If you have CATIA or SolidWorks, then you can also import geometry from there, but you should export geometry through the SolidWorks or ANSYS or CATIA into the IGS file, because ANSYS supports IGES format, and if you don't have the format of IGES, then geometry won't be in the running condition in ANSYS. You will face problems. So in IGES format, you face no problems. You can see that I've imported in some geometries in ANSYS Workbench in the IGS format. If, as you know, that SolidWorks save files in STL format, or CATIA do something like this, but make sure that you export your geometry in the IGS format before importing it into the ANSYS. Otherwise, ANSYS will not import or give some errors. But right now we are going to make our geometry in the new design modular of ANSYS. Okay, so go to new design modular. Now we know that there are three planes. Go to XY plane, click here, then go to sketching, go to rectangle, make a rectangle like this, and also change the units to inches. As you can see that our dimensions are in inches. Go to dimension, go to horizontal, give 3 clicks, 1 click here, second click here, and the third click over here. Now go to vertical, give 1 click here, second click here, and the third click here, 1 click here, second click here, and the third click here. So now you can see that this has a length of 49 inch, and you can also constrain it to the center, but I'm not doing that. I'm using my dimensions to make it into center. You can see out later on 24.5 inch, and follow me. Okay, 4 inches of width, and 4 divided by 2 is equals to 2, so 2 inches. So if I zoom in, then you can see that rectangle in the center. So now go into the extrude and go plus sign, sketch, click sketch, and then apply. And after applying it, because as we are doing a 2D type analysis, then we will make sure that we have a very small thickness of about 0.1 inch. Go here, generate. Now you can see it's a very thin surface, right, that we have just made. Now close it and go to model, double click here. So finally, it takes a little bit of time in opening, so you have to wait. Still it has not opened yet. I don't know what's happening. So now finally go here and mesh, and not mesh, go to static structural, go insert and insert a displacement, right? Come like this, or click on the X over here, then zoom in, right? And after zooming in, press control and the scroller button of the mouse and drag, and leave the scroller button and control. Now go over here, select this line, apply, and put y0. As we have simply supported beam, then it will restrict our uh, our movement in the y direction. So in order to model it, I have restricted the displacement in the y direction, and if we have to model it in 2D, remember that also, because we have to incorporate that in our simulation as well. So as we have simple supports on both sides, so going on to the other side, you can see that this is the negative axis. You can see that. Click here. Now you can see on the other side, zoom in, and then press control, scroll button, drag down, drag here, over here and there, right? Go to static structural, take another displacement, and select this, apply, and 0. You have restricted this movement, its movement in the y direction. Now go to put another boundary condition, displacement. Now control, okay, you like this. You can also use this ball to do that. So now over here you have to select this face, then select this face, apply, and you don't want to move this face in the x or z direction, because we are doing a 2D simulation in only y direction. So for that, pick it 0 and make this as 0 also. Now click here, zoom in, just like in the previous, and press control and drag through the scroller button. Now here, right click, insert, and pressure. So face over here, select this, apply, and pressure of 85 psi. Now solution, insert, stress, maximum principal, and insert stress equivalent 1 mises. Right click here and solve. So by the grace of Allah, it has been solved. So now see some simulation. So click this ball and play here. So you can see the simulation over here, and you can see that the mesh is very coarse. So in order to increase the size of the mesh, go here, right click, insert, sizing, click over here, click this is body and full body. Okay, don't select faces, just click here and select the whole body, apply, and here the default size is 2.4 inch. I will make it 1.5, no, 2 inch is okay. We will see 2 inch, and then we will go towards the mesh independence test. Now solve. So firstly it is doing meshing, and after doing the meshing, it is solving the model. So finally it has solved. So you can see meshes is still in the course, but somewhat better results. But in order to make results more stable, we have to go towards the mesh independency test. And for that, we make parameters. So now come here, body sizing, here. So this P comes over here. Okay, go towards the maximum principal stress and P over here. So I think average out is for better. Okay, average and equivalent stress. So taking maximum or average over. Okay, and after that, not average, take maximum, one average, one maximum, and then cut it down. So when you cut it down, you see the parameter set. This you won't find that if you won't have made the parameters, as you can see the P in the box that we have made just earlier. If we won't have made that, we won't have get this parameter set. So click here, double click here, and after double clicking, just put some sizes, but make sure that these sizes are lesser than this 2 inch that on which we have performed the simulation. Okay, so 1 inch and 0.9 and 0.8, 0.7, 0.6. That would be enough, and after that update all design points. So now it is calculating at all mesh sizes that what will be the result of maximum principal stress and maximum equivalent stress maximum. So now it will take a lot of time, and you can see time over here that it is 11:56 for January 2023. So I will pause my video recording, and after that we will come and check that what are the results. Now you can see that all their design points have been updated, and how much time it took, about 4 minutes or something. And you can see that the maximum principal stress average is about the same from 1 inch body sizing till 0.6, about almost same. So this means that it has stable results, and you can also see that it is 235, but it is 230 and it remained in that particular area, which means that we have achieved the mesh independency in the maximum principal stress average region. But in case of equivalent stress maximum, you can see that they are not stable results. So for the sake of the simulation, I did till the 0.6, but you can lower as much as your computational resource supports, and go up to like 0.1 inch and 0.05 inch and 0. I did simulation up to 0.05 inch, but if you can go lower than that, then do it and check that whether the mesh independency achieves in the simulation. I hope you like this video, and it would provide you with information on how simulation is done on ANSYS. Inshallah, we'll meet you soon, inshallah. Allah Hafiz.